Darasecom, learning without boundaries.
Welcome to our video today. Today we'll be looking at how to write chemical formulas of compounds involving polyatomic ions. Polyatomic ions is what we call radicals. Is simply what we call radicals. But before that, if you have not watched our first video on writing chemical formulas, kindly pause this one a little bit and go back there so that it makes it easier for you to understand this one. Now, polyatomic ions, or what we call radicals, is simply a group of atoms that react as a unit. They react and even form compounds as a unit. For example, if sodium was to form an ion, sodium forms an ion by losing one electron. When one electron is formed, a positive sign or a positive charge is acquired by the sodium ion. Now, this is only sodium atom forming a sodium ion. But when it comes to polyatomic ions, instead of having only one atom, instead of only having one kind of atom in the ion form, we have various types of atoms of different elements. Let me show you what I mean. For example, I'm going to group them depending on their charges. So here we will have those with a charge of 1, whether it is positive or negative. Here we will have a charge of 2, whether positive or negative, and here the charge of 3. Now, I'll start with the only positively charged ion that we mostly use in high school, and that is ammonium ion. Ammonium ion is written as that. As you can see from the formula, ammonium ion is composed of 1 nitrogen and 4 hydrogens, and it has an overall charge of positive. It has an overall charge of positive, and that is why I've grouped it here. The other one that we shall look at is nitrate ion. Nitrate ion, as you can see, nitrate has 1 nitrogen and 3 oxygen and a negative charge. The other one is nitrite ion. 1 nitrogen, 2 oxygens and a negative charge there. The other that we shall look at is hydroxide. 1 oxygen and 1 hydrogen and a negative sign. Remember, all these ones have a charge of 1, and it's only ammonium that has a charge of positive. The other one is hydrogen carbonate. The other one is hydrogen sulfate. Now, there is also another video that shows how you can remember the charges of these polyatomic ions, and if you have not watched that video, I would also encourage you to watch the video. It shows even how we get this negative sign and this negative sign, so it is pretty simple. Then let us go to 2. We have carbonate, we have sulfate, and we have sulfite. You note that I'm using capital C and capital O. Why? Because all these are different elements. So you must represent the element the way it's supposed to be represented. So I cannot write a capital C and a very small O, because that will not be carbonate. Again, if I don't include 3 here, if my oxygen atoms are not 3, that is not a carbonate, because for a carbonate, remember I said they react as a unit, specific number of atoms or group of atoms. Then the other one is phosphate. with 3 negative. I always tell my students it's very easy to remember these because most of them have a valency of 1. If you are able to remember that carbonate, sulfate, sulfide are the ones that have a valency of 2 and phosphate a valency of 3, then it also becomes very easy to remember that all the others are found here. So how then do we write chemical formulas with this information? And I'll start with a simple one. I'll start with sodium hydroxide. Sodium hydroxide. Sodium hydroxide. From the name, you can be able to tell the two ions. You can be able to tell the two ions that are combining to form the compound. One of them is, of course, sodium ion. Again, as said, there is a video that shows how these ions are formed, so make sure that you look at that video. Sodium ion combining with a hydroxide, right? A hydroxide. So hydroxide is OH negative. So how then do you write the formula? I want you to remember this. In the previous video on how to write chemical formulas, we said that when the ions combine to form a compound, their charges must cancel out to form an overall charge of 0, because compounds will always have an overall charge of 0. So if this one and this one combine, they should form an overall charge of 0. And this one is pretty simple because this one is positive 1 and this one is negative 1. Positive 1 plus negative 1 is 0. So this one will only need one sodium combining with one hydroxide to form sodium hydroxide. Pretty simple. Now let me go a step or a notch higher and try to write magnesium hydroxide. Magnesium hydroxide. Now, again, this one is very, very simple. In fact, you should have fun doing this like I am doing, because this one is simply magnesium ion 2 plus. If you have checked the previous video, it becomes easier. Combining with hydroxide, OH. All you need to know is the charge on these polyatomic ions. So, as I said, that the charges should total to 0. Here I have plus 2 and here I have minus 1. Here I have minus 1. So how do I make this one 2 minus, so that 2 plus 2 minus gives me 0? The only thing I need to do is simply multiply this one by 2. If I make this one 2, 2 of these plus 1 of these should give me a 0. So what will be the formula? The formula will be magnesium hydroxide, like that. Remember, this charge of magnesium and that one of hydroxide have gone. Why? Because we have added them, 2 plus 2 minus, to get 0. So when writing the formula, there is no charge. The compound has no charge. So that is magnesium hydroxide. I hope that we are getting on well. The other one I would like us to try and write is that one of potassium carbonate. Potassium carbonate. Potassium carbonate. From the name, it becomes pretty easy to know that I'm having a potassium ion combining with a carbonate, So here is my carbonate. We said that the total charge must always be equal to 0. So if this one is 2 minus and this one is 1 plus, I have to make which one 2? Of course, this one. So this one has to be 2. 2 of these combined with 1 of these to give me a charge of 0. It is important for students to know that we make this one 2 so that we can cancel out the charges to give us 0 here. So what do? We take this one, becomes 2, potassium 2. I've simply multiplied this one by 2. So potassium 2 and carbonate, like that. So that becomes the formula of potassium carbonate. As simple as that. I want to go a notch higher, and I want us to look at another one, that is magnesium nitrate. Now, magnesium is magnesium 2 plus, and the nitrate is here. Here is our nitrate. NO3 minus, like that. There is, now as you do them, it becomes easier and easier to know. One thing you have realized, that if I simply cross multiply these charges, the values of these charges, I get my formula. What do I mean? If I cross multiply the charges, the value in these charges, this one will become 2 and this one will become 1. So the formula will be magnesium into brackets nitrate. These 2 comes to the nitrate, and this 1 comes here. When you have 1, we don't write the 1. When you have 2, you have to put the radical in brackets and multiply by the value, because, as I said, the atoms react as a unit. So this one too must multiply the whole group of atoms, that is nitrate, multiplied by 2. So the formula becomes magnesium nitrate. So this value must be taken by the whole group of atoms. Some students will make a mistake. And they'll simply write magnesium. For example, if it is hydroxide, write magnesium hydroxide and then write a 2 here. Now these 2, what you're showing us is that these 2, we have 2 hydrogen atoms. If I'm to read out the number of atoms, what you're telling us is that we have 1 magnesium atom, 1 oxygen atom, and 2 hydrogen atoms. But when writing the formula, if you put it into brackets like this, what you're telling us is that we have 1 magnesium atom and 2 hydroxides So it is very good that you make sure that the radical, if it is taking a higher number than 1, you have put it into brackets. Let us finally, I want us, this is the second last, I want us to look at aluminium sulfate. Aluminium sulfate. Aluminium is 3 plus. Aluminium sulfate is 2 minus. Is 2 minus, like that. So as I have said, that now it becomes easier. If you know the charge here and you know the charge here, it becomes easier. You simply cross multiply the charge. So if I'm writing aluminium sulfate, these 2 I bring here, these 2, that is with sulfate, this 3 comes here, So that becomes the formula of aluminium sulfate. Pretty easy, right? So easy. In fact, you just need to cross multiply the charges. Very easy. A, B, C, D, drinking of water. Finally, so the other one that I would like us to do is ammonium sulfate. Ammonium sulfate. Sometimes students hear these names and they think that they are so big that you need to cram all of them. I always tell the students, if you can't remember only these charges, 1, 2, 3, how many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just 10 polyatomic ions that we mostly base in high school. If you can only remember these 10, it becomes very easy to write the formula. So take your time to go through this and know. And I always tell them that there are only 3 with 2. It's only 1 with 3. So every other of them, every other polyatomic ion lies in negative or positive 1. So we have ammonium sulfate. Ammonium is written as NH4 positive, sulfate SO4 2 negative. Now, this one is a polyatomic ion. And why have I written it on this side? And all the others I was writing them on this side. Because ammonium is a positively charged ion. It is a cation. It behaves as a cation. Therefore, all cations are always written on the left side and their anions on the right side. So if you're writing and you're talking of a positively charged ion, should be on the left, negatively charged on the right. So when writing the formula, we will have ammonium sulfate. We said we exchange, these two comes here and this one comes here. This is 1. When it's just positive, that means it is 1 or a charge. The 2 comes here, and so the formula becomes ammonium sulfate, like that. I would like you to try others and see whether you have understood, and do more practice. And as I said, you only need to remember the charges of these. Make sure you subscribe and make sure that you watch all our videos for more information.